Hey math fans, we're on section 2.7.1. Let's get started. An inverse function can be thought of any function that undoes something that's already been done. When you think of inverses, I want you to think of how could I go back to where I started. Sometimes it's very easy. Sometimes it's just doing the opposite, but sometimes it's not the opposite. The inverse of f of x is written as f to the negative 1 of x. Here I have two tables. One is the original function, and the other is the inverse function. What do you notice about the inputs and the outputs? It looks like the inputs and the outputs are reversed, which they are. Remember, this function is going to undo what has already been done. So let's take a look at some inverse operations here. So if you have a function that's adding, subtracting would be the inverse. Subtracting, adding, multiplication, division, division, multiplication. And square, taking the square root, you're going to be squaring the number. Cube would be cube root, and so on. If a function is one-to-one, it means that each x value is mapped onto one y value. Now, a linear function is always going to be one-to-one. For every x value, there's going to be only one y value. But what is not one-to-one is a quadratic, because for two different x values, you're going to have one y value, which means in the inverse function, you're going to have one x value with two y values, which is not going to be a function. For example, let's say I have the function y equals x squared. It's a parabola. When I do the inverse function, I'm going to be switching the inputs and the outputs, or the x's and the y's. So in the function, I'm going to switch x and y. And now I'm going to solve for y. Take the square root of both sides, keeping in mind that when you take the square root, you're going to put plus or minus. There's actually two answers to the square root. And then your final answer would be y is equal to plus or minus the square root of x. Now, if we consider both plus and minus the square root of x together, it is not a function. Take a look at the blue and the green graph together. It's not a function because for the one value of, let's say, 2, you have two different y values. It doesn't pass the vertical line test. It is not a function. So what we're going to end up doing is restricting the domain to maybe, I don't know, the x values are greater than 0, or perhaps the x values are less than 0, so that inverse function will be an actual function. Here are some common errors and misconceptions. Example 1, Lana's driving home from a friend's house. The distance in miles can be represented by the function negative 40x plus 15. So we want to find the inverse function. And so what we're going to do is we're going to write it as a normal function, except we're not going to use f of x, we'll use y. So we're going to say y is equal to negative 40x plus 15. And then we're going to switch the x and the y and solve for y. So now that we have the x and the y switched, let's solve for y. You're going to subtract x. You're going to divide by 40. Now that 40, be careful that you have to divide everything on the right-hand side by 40. And 15 over 40 simplifies to 3 over 8. So there is your inverse function. Of course, you want to write it in the correct notation, which is f to the negative 1 of x. Example 2 deals with a high school selling tickets to a play and how much profit you're making. So what if you wanted to know how many tickets you need to sell to make a certain amount of profit? Well, you could do the inverse function. So what we're going to do first is we're going to write y is equal to 12x minus 600 and switch the x and the y. And we're going to solve for y. Again, when you divide by 12, or in this case, negative 12, remember that it's both things on the right side that need to be, everything on the right side needs to be divided by 12. So 600 divided by 12 is 50, which will leave you with 1 over 12 as the coefficient of the x term. Replace p to the negative 1, which means it's the inverse function. So now you have the correct notation and the correct inverse function. Now finally, let's talk about this quadratic. So we have f of x is equal to 4x squared, and we need to use a restricted domain because a parabola, when you do an inverse, since a parabola is not to 1, your inverse will not be a function. So what we're going to do is let's let x only be positive, or in other words, x is greater than 0. We're going to make that our restricted domain, which means when it comes time to square root, we're not going to be considering the negative square root. So we switch the x and the y's. We solve for y. So we divide both sides by 4, and now we take the square root of both sides. Now I put plus or minus because you're supposed to put plus or minus, but we are going to disregard the negative root because we're restricting the domain. So we have y is equal to the square root of x over 2. And then we replace it with f to the negative 1 of x, and you have your answer. And that's going to do it for this section. We'll see you in class.